Resolving problems for drug development industry, being able to forecast natural disasters, and to make the pure AI breakthrough is going to be the fourth revolution in the near future thanks to quantum computers. First of all, let's familiarize ourselves with quantum mechanics. Well, energy quantization was the beginning of quantum physics. So, to understand this, initially we should know that all the tangible bodies in the world emit light, just like our daily clothes, for example. Although no true black bodies exist, imagine one
that has the property of absorbing all the light that strikes it, therefore it radiates energy accordingly.
And according to classical physics, a black body would emit the same amount of light of each frequency.
This means that
if you heat a metal up and up, eventually it would produce the ultraviolet light invisible to the naked eye, which actually isn't the case in reality. Hence, this problem was called the ultraviolet catastrophe.
And later, a physicist named Max Planck solved it and found that bodies do not emit light continuously, but through small packets called quanta. And his equation was...
Then it was deduced that a black body wouldn't be able to feed a high-frequency quanta with enough energy, thus it sticks with low-energy light. Finally, this became a fundamental basis for the start of quantum physics. Having developed it sometime later, a superposition was invented. To get the gist, let's call quantum realm as a small world, and the one we live, big world. A particle behaves like a wave in the small world, and this transportation is called the measurement problem, which isn't yet figured out how it happens. Hence, it is these properties that coin the term wave-particle duality. But now, let's get back to our quantum wave and turn it into the physical one by squaring the amplitude to get position and momentum. As a result, there is a probability distribution of a particle's position, meaning that the higher the amplitude, the higher probability of a particle being there. As you see, there is the same probability right over here and here, implying that an object can be at two locations at the same time. Consequently, this is called superposition. For example, if you cause the coin to spin, it is both heads and tails simultaneously while spinning, and it is said to be in superposition. Well now, time for entanglement. Let's assume that you have an implacable enemy who knows your mood all the time despite your geographical location, and imagine that you possess this skill as well. Then, we can say, when you feel down, your enemy gets happy, and vice versa. So, by knowing what's your state, we can instantly say that your enemy's state will be the opposite, and this communication, which is faster than light, is called entanglement.
While classical computers use binary codes which are ones and zeros, quantum computers use qubits that are ones and zeros at the same time due to superposition and entanglement.
All these properties make up the quantum computers, and I hope it's gonna be this generation who's gonna develop it further.